Hi everyone! In this tutorial we'll build this parametric butterfly valve in Revit. This butterfly valve will be controlled by a CSV lookup table. If you want to know more about CSV files, you can watch our other tutorials on this YouTube channel. So I will start with opening the two connectors PipeX template. First, I'll add a few reference planes. I will make them equal to each other, like this. And then I'll place pipe connectors. A plane, and I'll pick this plane here. And we'll add one more connector on the other side. Like this. Again, pick a plane. I'll set this value to 0 and mirror this pipe connector. And then we can go to front, and here we'll place these connectors correctly. I will also add labels. And one DN, yes, this, and another one will be and 2 DN. Great. Now we can go back to the reference level view. And here I will add a few more reference planes. And make them equal to each other. Now we can create a new Revit family, because we will work with nested families in this tutorial. I'll select family and choose model face based template, this one. And here we'll use the extrusion tool. I'll select this circumscribed polygon, change the number of sides to 8, like this, and we'll start drawing. Okay, and now we can add dimensions. Like this. Then I'll make both sides equal to each other. And we'll add a new label to these dimensions. We'll create a new label and call it W. Make it instance and click OK. Like this, great. And then we also need to add a hole in this element. Also in this case, I'll add a dimension. We'll make it a diameter dimension. And add a label, of course. Let's call it D. Okay, great. I'll click OK and we'll go to the front view because we need to add a dimension for its height. So let's do it like this. And let's call it L2, also instance. Roughly 40 millimeters, great. Yes, now we can save this family. I'll create a new folder and we'll call it Revolve or Revolve family. And this is going to be our body underline 001. Now we can load it into the project, into our host family. And here you need to first click place on vertical face. And then it will be possible to place it vertically in the project like this, and we can mirror it, yes. Then we'll align it with the center of our host family. All right. And of course we need to add new dimensions for the dimensions of our nested family. So here, for example, I'll create a new label, also W, also instance. For D, now of course I need to create a new one. Yes, instance, okay. We'll select it, and for this L2 I'll also create a new dimension. I'll add a few underlines as a prefix because on this way it will be easier to distinguish parameters for which we need to use size lookup formulas from those that don't require any formulas from other parameters. So I'll add a dimension here and we'll add a new parameter. We'll call it L. So it will be the full width of the body of our butterfly valve. Then I'll go to family types, and here I want to set the correct values for our dimensions. I'll create a new dimension and we'll create label for it. We'll call it L1 and make it instance. So if this is L1, then the middle parts of the body will have the L2 dimension, the L2 parameter, and we'll add a formula for it. Well, let's see. L2 will be L minus L1 multiplied by 2. All right, yes. I need to copy this dimension and then the name of this dimension, and then we'll simply paste it here. So minus L1 and multiplied by 2. Okay, now you see that this element has been placed correctly, and we can continue. We'll add a new dimension for the width of our butterfly valve. Before that, we were working on its thickness, and then we can go to its width. Right, so you see what happens. The geometry we created was placed correctly. Now we can continue with the next family. I'll create a new family, and for this family we'll use a generic model template. And here I'll use the extrusion tool again, and we'll use a simple line to draw something like 20, and here I will, I don't know, around 60. 40 will be the total width of this ear element. It's going to be near the ear of our butterfly valve. So here we can directly add new dimensions. Yes, so we'll need this length here, and then I want both sides of this ear to be equal to each other. In this case, I'll equalize them, and we'll need a dimension for the width of this element. So this one I'll call A. For the width, we'll add a B dimension, like this, yes. And this one is going to be small r for radius. I like this, great. All right. All right, this is it actually, so we can save also this family here. I will call it here underline 001. Now that we fixed this ear family, I will create a new family. It's going to be a face-based family this time. We can load it into the face-based family that we have created. This one. Okay, I'll place it here. And then I'll create dimensions for these parameters of the imported ear family. So here I'll create a new parameter. We'll also call it A. Make it instance. Also new parameter I'll call L2. And then the last one is our radius, which I actually didn't use. I was planning to use it, but eventually we didn't, as far as I can remember. So you can leave it like this. And in the next step, we'll create an array. So now you can leave this number of copies. It's not that important. Yes, 3, it is fine. And I'll extend the circle. And here's our array. Alright, so another thing we can do is we can join these elements. And now we can load it into our body family. Oh no, wait, into this host family butterfly valve. Here it is, and now we need to place it correctly. Let's say we could place it here and here. Yes, this is fine. We'll create 2 instances of the same family and then place it correctly. In the next step, I will create new parameters for the loaded family and link them to the existing dimensions of this family. So I'll start with this one, A. Yeah, I actually previously created them, so I'll simply select it from the list to the list. And this is going to be our B, and L2 is our L2. Yes, I guess this is it. Yeah. Sorry, I messed up. This the thickness of this array should be L1, so I'll quickly relink, or in this case, link these dimensions to the correct parameters. So again, underline A, E, and it's L1. Let's go to 3D view and see what's wrong with our second family. Oh, it actually nothing is wrong. It's just rotated in another way, which yes, well, fix it like this, and then we can place it correctly. I'll set this height value to 0 like this. Great. So okay, we already created these parameters, so this is our PCDC parameter, which will control the diameter of the array. So it is set to 210 millimeters, which is correct. And another thing we need to do, we'll use a formula for the length parameter of an ear in our array, and we'll set it to PCDC divided by 2. Let's see if it works. Yes. Okay, great. Well, it's not perfect, as you can see, because this one ear is protruding beyond the edge of our body element. So what we could do, I think we could add to our formula that we wanted this this value we want to be multiplied by 0.98, and now you see that it became a little shorter. I'll make it like this. So I will select this array and edit family, and here I really think that I will add a parameter that will control the number of ears in our array. So I'll add a parameter here and we call it BQ, like this. Great. And now I'll save it ear array, this, and then we can load it into our family. It's in this case butterfly valve family. Let's check it. No, because we renamed it, it won't be updated. So let's see. We'll add a label, call it BQ get instance, like this, and then we'll load it into our butterfly valve, override it. So what do we see here? Yes, now we can see this parameter. The rest is linked. We'll create a new parameter for this BQ parameter. All right, so let's go to 3D. Where's our geometry? And here it is. Okay, I'll change the display options and enable shaded representation. So we can do here, we can mirror this element. And now I go to family types, and here I want to change the number of ears in our array. I will change it from 3 to 8. Click apply. Okay, so here's our array, and here for this instance of this array, we'll also need to link this parameter BQ that we previously created. All right, so let's go back to, or better say, let's go to front. And here I want to rotate this array so that the central reference line is located between the two ears of our array. So what I will do, I will select rotate, and then alright, first you need to remove constraints because we just got an error message, but now we can rotate it again. Let's say to something like, what did I say? Yes, 22 degrees. And now we can do the following. I'll add an angular parameter, angular dimension here. And for this dimension, I'll add a new label. We'll call it, let's see, something like A, underline A, or even A and G for angle. Make it instance, and I will use a formula for this parameter. So I'll go to family types, and here find this parameter and add a formula. So basically we want 360 to be divided by well, actually by 8, and then divided by 2, because we calculated the angle between the two ears, and I want the central reference line to be between these two ears. So let's see what. Yes, 22.5 degrees is the correct value. So now I need to go, we could go to back, and here we'll do the same thing. Yeah, also here I'll simply add an angular dimension on the other side, why not? Okay, now it looks right. We can go to 3D. Yes. Let's just the way I want it to be. So now we can continue, and I will create a new family, and again it is going to be a face-based family. So here I will use the extrusion tool and will draw a circle. I think we need something around 80 maybe. And of course we want to control its diameter, so I'll add a dimension, and it will be a diameter dimension. We'll label it, so let's call it like E1. Don't forget to go to the front view, finish extrusion, and create height dimension. Like this, great. Then I'll save this family. Oh, we'll call it body underline 002. And then we can load it into our main host family butterfly valve. So here we need to place it correctly. I created 2 instances of this family, and now we can adjust the location. Yes, I will click the padlock to make sure it will remain at place. And for this, oh, it's difficult to see. I think it's the middle, the center of this family, and here we go. Yes. Now I'll select this the imported family, and we can link the dimensions of the host family to those of the loaded one. So here, for example, for D, I will select D, L1, also L1, D1. I think that we'll need to create a new dimension for this one instance. Yes. Okay. So here D1 and D and L1 like this. Great. So let's see what we have. We can see it because likely it's placed too high in the project view, so we can go to front and quickly fix it. Like this, and now again I'll check what we have here. Well, obviously the D diameter is too small, so I'll go to family types and we'll change it. So it is currently set to 23 millimeters, which feels too small, so I'll change it to 46 and click apply. No, it's also not enough. So likely it is something around 86 or so. Looks better, but still I'm not really satisfied with the results, so let's set it to maybe even 100 millimeters. Looks better. I think we can leave it like that. So next I can join this lining with our array. Now I can join the geometry of these two families, like this. Okay. In the next step, we'll create a void for the hole in our butterfly valve body. So now I'll create a new family. I will use the extrusion tool, and here we'll draw a circle. We'll add a dimension, make a diameter dimension, and of course we'll create a label, D label, like this. Then you need to change the type of geometry from solid to void. Click OK. And then don't forget to check the box cut with voids when loaded. Otherwise it won't be possible to cut the geometry with this void. That wasn't difficult. Let's continue with the next element. I will go back to the reference level view, and here I'll go to create extrusion. and create a simple rectangular. Click the padlocks and then click OK. Now we can go to front, and here we'll correct the height of this element that we created. Just a second, I want to change the scale because I couldn't see the geometry we created, and then I will align it with the edge of the butterfly valve body, and on the other side we'll create a new reference plane. And align it with this reference like this. Then we'll need to add a dimension, of course. I'll add one more reference plane because this way we'll simply make this the two elements that we are about to create equal to each other, and it will save us a lot of headache later. So one more reference plane. I'll add a dimension, equalize them like this. Yes. And we'll need another dimension here. For this one, I'll create a new label and we'll call it 2. Make it instance and click OK. For the next element, I will use the revolve tool. So I'll go to create, revolve, and here we'll create a new sketch. Click the padlocks, as always, and pick the axis of rotation. This one here. Okay. And of course, we'll need to add a dimension for the new reference plane. I won't add any labels here. I simply will set it to 30 millimeters and click the padlock. All right. So let's see what we have in a 3D view. Yes, it looks good. Now we can continue with the gearbox and hand wheel of our butterfly valve. I will create a new family. It will be a simple generic model template. And here I'll add a few reference planes first. Okay, so I'll make all the reference planes equal to each other. Then I'll add a few more dimensions that we need to control the geometry size. This one here will get a D label. No, let's call it D2 instance. Okay. And I'll need one more dimension over here, and this this dimension will get the parameter we'll call A2, also instance, like this. Great. Then we can start creating our geometry. I will use the extrusion tool, and here we'll use a line to draw the form we'll later extrude. So let me start over here, and then it will go diagonally like this. This is going to be our gearbox. Yes. Now I'll click finish, and we'll go to front. In this view, we'll add a new dimension for the height of the gearbox. I'll add a new reference plane, and then we'll align it, the edge of the gearbox with this plane, and like this. And yeah, I think that's enough. That's actually enough. So I'll simply say that I want them to be equal to each other. Then we'll add a dimension for the whole height in this case. As always, we'll add a label H3 instance. Yes. All right, so now we need to create a few more elements for our gearbox, and this will be a cylinder, and on the top we'll have a box. We'll go to this view instead, to the left view, and so we'll create our revolve from this view. So now I'll go to create, select revolve, and here in the middle of our gearbox, I will draw a rectangular. Click the padlocks, draw a new axis line, and click OK. So this is our cylinder. We can go back to the reference level view now. And the last thing we need to do is create a box on the top of the cylinder. So we'll need 2 more reference planes, maybe a few more. Yes, like this I would say. And so I want them to be simply locked between the existing reference planes, so I equalize them, so I make them equal to each other. And now we can go to the Create tab, and here we'll use the extrusion tool this time. I will draw a box again. Let's say like this. Click the 2 padlocks that are visible in the view, and then I will, you know what, I'll add a dimension here in this view, and yes, it will be length parameter. This element will create a new label, and let's call it A, underline A. And then we'll use a formula to control the length of this element. So now we can go to family types, and here I want it to be, let's say, a formula should be used. We have A2 parameter, so we can use this parameter in our new formula, saying that we want it to be divided by, let's assume, by 3. Will that be enough? No, it's not. And moreover, I see now that we forgot to align it with the center of our gearbox. And say that additionally I want it to be always in the center of this element. So now we can go back to family types and use another formula. So maybe we'll say that I want it to be multiplied by 0.90. Yeah, that's because we need to add a point here. Like this. Yes, it's fine. Yes, it is just fine. Now we can go to front, and here we'll adjust the height of this element. Like this, great. Let's go to 3D and see what we have. Yes, that's our gearbox. I'm quite satisfied with the result. Let's quickly check if we have all the parameters that we need. So this one is for height, and then A2, and I also needed D2. Yeah, seems to be fine. Now I will save this family as always. Simply call it gearbox, and then load it into the butterfly valve family. Okay, it seems that we need to adjust its position in the view. And the size is also, well, you can see it's just huge compared to the body of this element. So wait a second. All right, so we can move it and then we'll align it using the align tool like this. Great. The next step, I'll go to family types, and here we'll set the correct values for the parameters. But first I need to select this gearbox and create new dimensions, create new parameters for this existing dimensions. So let's quickly do it. A2 instance, yes. Oh. Let's call it AB because I don't want, oh, wait a second. Yeah, I don't want it to be confused with any other parameters, so instead of underline A, I will call it A underline A N. Doesn't matter what name you use here. Alright, yes, like this. And now we can go to family types and set the correct values for the parameters. So in our case, we'll need to set this value to H3 to 92 millimeters. And see if it works. Yes, it worked great. And it's still too wide and too long, so this is controlled by dimensions by D2. Yes, right. So I'll set it to 122 millimeters. But you can see that it's still a way too long because we forgot to add a dimension controlling the length of this of the geometry. So since we have this D2 parameter, we likely can use it for oh, wait a second, maybe we can use A2. Okay, so let's go back to this view and find our A2 parameter, set it to 64 millimeters. Click apply and no. Answer is no. Because we will need to change it. Why? Maybe it's because I don't have a dimension for these two reference planes. So let me, okay, so now you cannot do it. So then I can set this value to 37, just like all the others. And then we'll try no, and why? All right. Add a new dimension and we'll assign the A2 label like this. Alright, let's load it into the project again. Override the existing version. So this is what we have. It's okay. Oh, if you want, you can adjust its length. It is all controlled by this reference planes that we created, by the grid of reference planes. So it's always possible to adjust it, and in this tutorial we'll continue with the hand wheel. So I'll create a new family. Again, it is going to be a generic model family. Also here I'll start with creating a reference plane, or yes, you can call it a grid of reference planes. So I will copy this plane and so also in this direction I added a few reference planes, and now we can create a revolve. So I'll use a line tool to draw the profile. And how can we do this? I need to think first. So I'll start like this and then go here and maybe, I don't know, okay, you see that a few more reference planes would be helpful. But what we can do now is finish and then maybe add a new reference plane. So how to do it? Okay, I think I'll confirm it. Oh yes, don't forget to specify the axis of rotation. Like this, great. And just one more reference plane that I'll add. Here we'll say that it will also be equal to all the other reference planes. The distance, and well, let's make it a bit narrower, because now it's a bit more narrow, because now it's a way to... So this is actually fine, and maybe I will move this, you know, reference plane over here, remove constraints, and then click the padlock again. Let's check if they all are, yes, locked, yes. Okay, and what about this one? Oh yes, right, this is what I wanted to do. So, yes. Okay, the rest seems to be okay. Now we can finish edit mode. And of course, we'll need to add a dimension here. Let's create a new parameter and call it D3. It will be the diameter for our hand wheel. And of course, we want to control its length. But also, I'll create a new parameter. Let's call it underline A1. Okay. So what else? Gearbox, this one. Okay, and let's see if it's possible to flip this. This gearbox. Oh, this hand wheel. Yes, okay. Now I want to align it with this reference plane, as always. Yes, and the center I'll align with this reference plane over here. All right. Let's check if it was placed correctly. 3D view. Well, yes, it lays somewhere at the bottom, so I still need to correct it. It's not that important in this case, so I will simply say that remove constraints. Oh, wait a second. Oh, okay, yes, we locked it. Yes, so what I wanted to do, I want to align it with this reference plane. Okay, like this, yes, it looks fine. So now we can save it again, and load it into the butterfly valve family. Yes, you see, so the problem is that we have several problems over here actually. And not only it's way too far from the gearbox, but also it is just too big compared to it. So I'll go back to this family, and here oh yes, I see. So we removed all constraints, which is why the geometry wasn't really linked. The geometry didn't stay at place. So now we corrected it, and let's check if there is a yes, so these two lines are aligned with each other, apparently. Okay, let's load it one more time. Overwrite, yes, now it's in the correct place at least. And we can we need to add dimensions over here. So for this one, we'll create a D3 new parameter. Yes, A1 also new parameter, and for AN, what is it called? A1? Well, it doesn't matter. Let it be AN, and this is it, I guess. Yes, only these two dimensions. All right. I'll quickly save it and reload. Override the existing version, and now we can do the following. We'll create a D3 parameter in our host family like this, and then for AN I'll create AN already exists, so let's try A1. A1 is fine. Okay. And now I'll go to family types, and here we'll set the correct values for these parameters. So let me start with D3. I'll set it to 160. It's actually almost correct. Apply, and let's see if it works. Not much changed because the value is also not much higher than it used to be. So A2 is 64. For this dimension here, we'll use a formula. At first, I will create a new parameter, and so this is going to be A1. Apply, and then we'll go back to A1, this one here, and for this parameter we'll define a formula: A1 minus half of D2. Like this. Apply, and let's check if it worked. Yes, great. At the same time, we see that something is wrong with this hand wheel, because its central element is too thick, so I'll edit this family. And here I think we'll create a few more reference planes and log them between these planes here, like this. Edit, revolve, and what I want to do, I want it to be moved, remove constraints, and add a new constraint. Pick the padlock. Yes, it should look better now. But it wasn't a mistake, it's just it looked too thick, but actually it's not wrong the way I did it. So now you can save it and reload it to this family first. Write this version, okay, and then I'll load it to our main family butterfly valve. Also override. Now it looks better. I'm still not quite satisfied with the diameter of this part here. Oh yes, it's too big. So maybe we could go back to this family. What was it? Yes. But again, I must say it's not a mistake, it's simply the way it looks. So we corrected it, and now I need to reload it to gearbox first. Overrides. Yes, and then we'll save it again and load it to butterfly valve. Override. Yes, great. It looks better. You still can say that it's a bit too thick, but you know, it's not that important for the purpose of this video, for this tutorial. So I will continue. I will go to front, and here well, we want to adjust the position of this hand wheel, but it would be actually right to do it here. Let me think about it. Here in this file, I can check the workplace based. I can check the work plane based box right here. Then we'll save this family again and load it into the gearbox family. Override the existing version and its parameter values. Now, since it's not possible to change the height because Revit will remove constraints that we have. So we need to remove them ourselves. Remove them ourselves, and then let's try one more time to this dimension. This parameter I can already delete. We won't need it, and this value I want to set to, for example, 92. Apply. Okay. check if it works. And yes, you see this. You see that our hand wheel remains at place at this reference plane, at this level, at the same level. Alright, so now we can save this family and we'll load it into our butterfly valve family. Override the existing version like this. And here it is. Let's check it in a 3D view. In the next step, I'll go to Family Types. And here I'll click Manage Lookup Tables. We'll delete this old table and import a new one. I will type in the name of our CSV file that we're using in this project and click Apply. Okay. Now that we added all the necessary formulas, let's check if our geometry works. Let's go to family types and see if our geometry adjusts to the changes we make. And here's the parameter that I will change. So let's set it to 100. So you might have noticed that obviously something doesn't work the way it should. So now we need to fix it somehow. Let's start with the body family. So I'll go to the this family, and here the problem is likely the geometry doesn't adjust properly because I didn't add angular parameters. Okay. Would I? All right, and I'll do it for all the angles here. Simply say yes. Want it to be 135 degrees like this, and then we will close the padlocks, and I'll do the same thing everywhere. All right, okay, so now I'll click finish and we'll save this family and load it into the project. Overwrite and overwrite its parameters as well. Now I'll go to family types, and here we'll need to add one more parameter that is currently missing, and it will be bolt diameter parameter. So actually I decided not to create holes in this in the ears of the butterfly valve, but we'll need this parameter because otherwise it will be difficult to control the size of the ears. Yes, I created this parameter, and then we'll need to add a lookup formula for it. And then based on this parameter that we've just created, we will change one of the existing parameters. I will delete this value here, and instead we'll type in something different. It will be plus parameter than that we just created, our bolt diameter. And divided by 3. Great, so let's see. Yes, now it looks much better. You noticed the ears of the array became longer, and they look actually the way they were supposed to look. it's fine for now. And of course, you see that there are some issues with the geometry between the gearbox and the butterfly valve body. So I will simply delete these elements, and then we'll need to find a solution. First, I will align this reference plane with the bottom of our gearbox and click the padlock. Then I want to add a few dimensions. I only need to see what would be the best way to do it right now, so I'll delete this reference plane too, and then we'll draw a new reference plane starting at this point and over here. Let me quickly do this. Select it, and now we can align this edge with the reference plane. And then we need to add a parameter controlling the size, of course, and the same we'll do for, wait a second, same we'll do for this reference planes here. Okay, so this, and also here we'll add a new parameter. Let's call it underline W1, and this parameter over here will be D3. I like this, great. And now we can go to create, revolve. Here In the front view, I will draw a rectangular over here. Yes, click the padlocks. I will zoom in to be able to select the right element, and then we'll specify the axis of rotation. Click OK. And then I'll go to extrusion, and this time we will use this tool to create our next element. This one here. Close all the padlocks, click OK, and then we'll go to reference level view, and here I will adjust its position in the view. So we'll start over here and end somewhere over here, I would say. Let's check it in 3D view. That's what we have just created. We can quickly join the ears with a string, this element. The same thing I will do on the other side. All right. So now I'll go to family types, and here I want to make sure that I added all the required formulas. For this dimension, we'll also need a formula. Here we need to type in the new value. It's going to be W2. Okay, let's use the same formula for this parameter. And here we'll type in okay, I'll click apply. Okay, and now let's check if our geometry works. I'll try to change the one parameter that controls our geometry. So instead of 125, I will use, for example, such as 100. Click apply, and yes, it seems to work. Let's try one more time. And this time I will use something like 200. Let's see if the geometry adjusts in a proper way. Yes, I would say that it works. Here's the result. Of course, this butterfly valve could be more detailed. Of course, this butterfly valve could be more detailed. For example, we could create holes in the ears. But for the purpose of this video, I think it's not really important, and I can see that this tutorial already has a long duration, so I think this is it for now. I hope you liked this video, and see you in the next video.